Okay, pre-calculus. Well, I hope you're enjoying your time at home. And let's learn some word problems types 3 and 4. So the great thing about word problem type 3 is that they've studied some sort of life event, and there's going to be all these variables right here that they have to find, okay, positive real constants from life. Okay, so the great thing is that these constants are given to you in the equation. So there is no equation that you have to memorize. Okay, for example, it says here that the wildlife reserve of the population of bears after T years has this model. Okay, and here's all the information, all the constants that they've already calculated. Okay, question part A. How many bears were there initially? Now, initially means in the beginning of time. Well, if you are in the beginning of time, how many years have passed? That's right, it's going to be 0 years. So initially means you always let the time equal 0. So question part A, I'm going to plug in a 0. So it's going to be P of 0. Okay, so that's kind of like f of x. We're putting 0 into the t spot right there. So we have 300 divided by 1 plus 19 e to the negative 0.3 times 0. So 0.3 times 0 is 0, and e to the 0 makes 1. So we have 300 divided by 1 plus 19. So 300 divided by 20 makes 15. And what does P stand for? The population of bears. So they put 15 bears into this wildlife reserve. Okay, now question part B. According to this model, when will the population be 150 bears? Well, I know that it's not going to happen overnight. 15 bears need to take some time to turn themselves into P 150 bears. All right, let's get our equation set up here. 1 plus 19 e to the negative 0.3t. Now I am going to walk you through the algebra and how to solve this. So the first thing we need to do is put 150 over 1. Now we're going to go ahead and cross multiply. So 300 times 1 makes 300. And then make sure, be very careful here when you cross multiply. 150 times this entire denominator here, 1 plus 19e to the negative 0.3t. Be sure to use parentheses. Maybe what I should do is add the 1 and 19 to make a 20. Clean this up. No, those are not like terms. He's got an e. You cannot do that. So the next algebraic step we're going to do is to divide both sides by 150. So 300 divided by 150 is going to make a 2 equals 1 plus 19e to negative 0.3t. So a lot of the work here with these types, type 3, is going to be algebraic, non-pre-calculus work until the very end. The next thing I do is subtract a 1. All right, and the next little baby algebra step that I'll do is divide by 19. 1/19 equals negative 0.3t. Okay, we're getting there, but I think that I'm finally, oops, where's my e? I'm finally stuck with my variable in a power. So now what I'll do is change to log. What kind of log? Yeah, natural log. Natural log of 1/19 equals negative 0.3t. Now you want to hold off with typing anything into your calculator until the very, very end. Or if you do, you want to make sure that you math fraction it up so it's exact. The way that we would get to the t here is to divide both sides by negative 0.3. And t is approximately, go ahead and type all that in. Make sure you close your parentheses. And the answer is 9.81. What is this? Years. So we've got 9.81 years. You get your time units from reading the problem. Okay, let's do it again. Fruit flies are placed into a milk bottle. Excuse my arm while I take my paper down. Okay, of course they need a banana and some yeast for food. You give them a nice place to live, you give them some food, and they've even given you the equation here. T is days, and this is fruit fly population. Okay, question part A. How many fruit flies were there initially? Remember, when it says initially, that means we're going to let T be a 0. Okay, here we go. Question part A. P of 0. So we've got 230 divided by 1 plus 56.6 e to the negative 0.37 times a 0. 0.37 times 0 is 0. E to the 0 makes a 1. So we've got 230 divided by 57.6, which is about 3.99. Okay, but wait a minute. P represents fruit flies. I really don't think they put 3.99 fruit flies initially into this bottle. So in order to be, nice humans here and not rip off any of the wings, we're going to say that they probably put 4 fruit flies into the bottle. Okay? If it's humans or animals, we're going to go ahead and round. If it's things that could be decimally, then go ahead and leave the decimals. Okay, question part B. When will there be 180 fruit flies? All right, let's see how fast these fruit flies can multiply. I put 4 in the bottle initially, and how long till I have 180? So 180 is going to be the P, the population, the final amount. 180 goes right there. We have 230, 1 divided by 56.6 e to the negative 0.37, and what we're going for when it says when, we're solving for the t. Okay, how do we solve a problem like this? You put 180 over 1, and then we cross multiply. So we have 230, and make sure when you cross this way that you use parentheses. 1 plus 56.6 e to the negative 0.37 t. All right, we're going to do some baby algebra. The first thing that we'll do is we'll divide both sides by 180. And maybe what I'll do is math fraction it up. So that's 23 over 18 equals 1 plus 56.6 e to the negative 0.37 t. Then I'll go ahead and subtract a 1. Subtract a 1 from both sides. So that's going to give me 5 over 18 equals 56.6 e to the negative 0.37 t. Now we have to divide both sides by 56.6, and this is where I definitely want you to have your calculator technology help you. I don't want any chopped decimals because then I'm going to continue working with them and my answer will be slightly off, and Mrs. Braytek's going to take a point off if it's not as accurate as possible. So when you divide in your calculator by 56.6, please find that math fraction button and turn this into the exact fraction, 25 over 5,094. Go ahead and take a second to do that and pause the video so you will definitely know how to do this. I think we're finally ready for some logs. So we'll use a natural log of 25 over 5,094 equals negative 0.37 t. After you type that in, you're going to have to divide by negative 0.37. So t is approximately, go ahead and find out how long it takes these flies to get that large. 14.37. And what's the units for this problem? Days. 14.37 days. Okay. All right, on to the last type of word problem. The last type of word problem is Newton's law of cooling. They also have Newton's law of heating, but it's the same kind of process. So we're just going to introduce one type to you, and mathematically you could do any kind of equation you want once you know logs. Okay, the scary thing about this is there's lots of t's. So we're going to go ahead and work through what all these t's mean and which ones you have to memorize. Okay, so when you take a hot object, like sometimes people cook a hot pizza and then they put it on the counter to let it cool off. So there's all this cool air in the room cooling off the pizza. Or sometimes people take eggs, boiling eggs, and then your mom probably puts them into nice cold water to cool them off. Okay? So you take things and you put it in a medium. A medium. That's the surrounding air or water. Sometimes people put things into sand to cool it off. We don't really do that with food a whole lot, but whatever's surrounding it, okay? So this T right here, this is your final temp. Okay, everything on the left is always final. Then we've got T sub M, okay? And that's that M, that's the medium. That's the temperature of the medium. The medium. And what's the medium? That's the surrounding whatever. It's usually the cool air of the room or the cool water you put it in. T naught, everyone should know that that is the initial temp. That's your initial temp. Okay. K is going to be the cooling rate. The cooling rate, because this is Newton's law of cooling, we're only cooling all objects down. And that little t is time. Little t is time. Now the thing is, I noticed this equation right here, e to the kt power. Remember class, that looks very much like type 2 when it was n naught times e to the kt. So this is going to have a couple of steps to it, just like type 2. If you're good with type 2, way to go. The first thing you have to do is you have to find the k. You have to find, I don't want to say it's a decay rate. My pizza's not decaying. I'll call it the cooling rate. And then step 2 is how you answer the question. Okay, so to do this next example right here, what I want everybody to do is separate their paper down the middle, okay, just like we did with type 2s, because on the left, what we're going to have to do is find K, and then we can use that over here to answer the question. Okay, so let's read this story here. So we have to make sure what all these variables are talking about. A hard-boiled egg at temperature 96. That's how hot this egg is. That is the T initial. Okay, that's how hot the egg was. And it's placed in, some nice cool water, 16 degrees Celsius water. So what kind of temperature is that? Yeah, that's the surrounding. That's the medium. 4 minutes later, okay, that's going to be our little t time. The temperature of the egg is 45 degrees. Okay, so that's the final. Okay, and then there's a period here. The reason they told you about this egg after so many times, all this information is to help you find the K. Here, use Newton's law of cooling to determine that is the question. So you cannot use 20 degrees when you're finding K. You have to use all the facts. Okay? You have to memorize these equations. So what I want you guys to do is look very closely at this equation. Okay, I know e to the kt is just like last time. How many subtraction signs do you see? You just see one subtract and one add. And what I've told people in the past to help them remember this right here, all these t's, is you have to think of your mom. It goes M-O-M. Okay? There you go. All right, so give me a final temp. Here, let's write the equation out for practice. Temperature equals temperature of the medium plus the quantity temperature of the initial minus the medium. There's my MOM, e to the KT. All right, the final temperature of the egg was, 45 degrees. Okay, the medium was 16. The initial was 96 minus that 16. So you use the medium twice. And then we've got e to the k, I'm going to find out, and the t, the time, is 4. All right, it's time for baby algebra. Can we put these two numbers together real fast and make an 80? Well, in this case, yes, because of the parentheses. Okay, so what I'll do first is subtract 16 from both sides, and I'm going to go ahead and write an 80 there. So 45 minus 16 is 29. equals 80e to the k. I'll say 4k. And then we'll divide both sides by 80. So 29 over 80 equals e to the 4k. I don't think there's any more baby algebra that we can do. So let's use a natural log. The natural log of 29 over 80 equals 4k. We'll go ahead and divide by 4. Okay, and I want to ask you guys, do you remember how I told you last time I saw you to deal with a triple decker just so that we have less typos and more success? Let's write this 4 as 1/4 natural log of 29 over 80. Okay, so this is the exact value of k that we are going to use in our calculations over here on the right. Okay, let's switch colors and go over here because now we have to answer the question. Okay, what was the question? Determine when the egg will be 20. So what is that? 20 degrees. That's going to be the final. The final. If I wait for more time, it's going to cool off. I know after 4 minutes, it got down to 45. I'm going to have to wait a little longer than 4 minutes. So that's going to be the new final. Okay. How about the medium? Well, the medium never changes. Okay, and your initial never changes, 96 minus 16. So whatever you had over here is going to stay that way. We've got E, and then we have our K value, which is 1/4 natural log of 29/80ths, and then we've got our T, which we're going for. So we could do a lot of baby algebra here before we even have to do our log work. So step 1, let's subtract 16. Subtract 16, that's 4 equals 80. E to the 1/4 natural log of 29/80ths t. Okay, and now we could divide both sides by 80. And it's your call whether you want to leave this as 4/80ths or reduce it and make it 1/20th. It doesn't matter the calculation in the end, but if you math fraction your calculator, it'll reduce it for you. I think that's as far as we can go with baby algebra, so now we have to use logs. Let's use a natural log. Natural log of 1/20th equals 1/4 natural log of 29/80ths t. Try to make everything fractions and don't type anything until the very end so it's as accurate as possible. Okay, does anyone remember how to get rid of this 1/4? Just like type 2. Yeah, let's multiply both sides by 4. How are we going to get rid of natural log 29 over 80? Okay, we'll go ahead here and divide by 29/80ths. 29/80ths. Okay, so t equals, you type all that in, magic, magic, and I will wait. And the correct answer is 11.81 minutes. Okay, there you go. Wait about 12 minutes and you can put that hard-boiled egg in your mouth without burning yourself. Okay, let's see. We've got one more Newton's Law of Cooling here. All right, we have an object heated up to 100 degrees Celsius. Okay, so what's that? 100 degrees, that's going to be the initial. And then it's allowed to cool in a room, whose air temperature is 30. Okay, that nice cool room, that is going to be the medium. Oh, I hear my kids crying. If the temperature of the object is 80 degrees, after 5 minutes, okay, if blah, 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 comma, when, that's starting a question. Okay, so we have to stop right here. All this data is to help me find k. Remember how I had to separate our paper down the middle? You cannot use the when part. That's a question. That's going to be the questions over here that we answer. So it says 5 minutes, little t. It got down to 80. That's going to be a final that I use to find k. All right, so let's see. See if everyone can write down the formula without looking. Are you able to get it? Good. Okay, give me a final. 80. Give me a medium. 30. Give me an initial. 100 minus the third. That's always going to be minus. Your object's always going to be cooling off. E to the k times 5 minutes. All right, let's see how much baby algebra you guys can do. Move everything over as much as you can and get all the way e to the 5k. Math, fraction it up, make it real clean. Okay, what you should have gotten is 5/7. So then we'll go ahead and do some logs. Natural log of 5/7 equals 5k. And when you divide by 5, remember I want you to write 1/5. Okay, there's your k. We're going to go ahead and use that over here to answer some questions. When will the temperature be 50 degrees? Okay, so that's going to be the final. So question part A, 50 equals 30 plus, I can go ahead and write 70 e to the 1/5 natural log of 5/7 t. So minus the 30 and divide by the 7. Do all your baby algebra and you should get 2/7. E to the 1/5. Remember, make sure you put 5/7 here in parentheses. And now it's time to do some logs. Natural log of 2/7 equals 1/5 natural log of 5/7 times t. How are we going to get that 1/5 out of there? Times both sides by 5. Then we'll divide by this natural log right here, natural log of 5/7, and time is going to be 18.62 minutes. Okay, there is another question here, part B. I want you guys to go ahead and solve it. Maybe pause while you set up your equation, and then I'll show you the equation. So the equation is 35, because that's the new final. And then we've got 30 plus 70 e to the 1/5 natural log 5/7, and now you're finding t again. Okay, why don't you pause the video again, go ahead and calculate, and see if you can find the time. And the answer is 39.22 minutes. Okay, I hope it's looking good. I want everybody to practice the word problem homework that goes along with this lesson. Okay, the homework word problems types 3 and 4. And make sure everyone has all of their note cards completed when I see you on Monday. Good luck. Thank you.